Hello and welcome to my introduction webinar related to managing piping loads on the pumps. My name is Zdravko Ivančić and I will give you a brief overview of what is managing piping loads on the pumps all about. Just a second, there are a few more people. Okay, so managing piping loads on the pumps is presented or will be presented through two webinars and one ebook. I will be presenter on these two webinars. First webinar is scheduled for July 11, so next week, next Tuesday at 1600 hours Central European Time, and duration of this webinar is planned to be 1 hour. Second webinar will be 1 week later. Again, the duration will be 1 hour. And then after these two webinars, you will all registered attendees for these two webinars will get ebook, which will be available probably 1 week after the second webinar. Now I will give you just a short info what will be the content of each of these two webinars. A little bit later, I will talk a little bit more in detail about the content. So as you can see on this slide, the basic content of the first webinar will be, I will talk about pumps and industry, pumps in different industry. I will talk about piping loads, which are the piping loads or which are the loads which can be transferred from the piping to the pump connection to the pump. I will talk a little bit about codes and standards and about pipe stress analysis related to the piping connected to the pump. And there, hopefully, there will be some question and answer at the end of this webinar, first webinar. Second webinar, the content is that we will go more in detail regarding the pipe stress analysis of piping connected to the pumps. I will present some of the methods and strategies, how to solve the problems on the pumps, when you have problems, of course. You will see several examples, and at the end there will be a conclusion with most important thing related to the piping and piping connected to the pumps. And of course, question and answer at the end of this webinar. And as I mentioned, ebook will summarize everything, will cover everything from the two webinars, and it will for sure contain some additional examples, and maybe even will contain some additional things which maybe we will discuss during our webinar, and then during our two webinars, and then I can add these important things also to the ebook. So the question, why should you register for my webinars, and why did I create something like this, or why I create these webinars? During my plus 20 years of experience with all aspects of piping design and calculations, I gathered a lot of experience and knowledge collected through working on various projects, but also learning from older colleagues. And it seems to me that it's time that I share my knowledge experience. As a pipe stress engineer and Caesar 2 instructor and consultant, I get regular questions for help and instruction related to the issues with the pump loads. So all this, let's say, all this is a reason why I prepare something like this. So suppose you are involved in designing, installing, operating, or maintaining piping systems connected to the pumps. This is something what is important for you. In this case, you know how important it is to manage piping loads properly. Piping loads can have destructive effects on the pumps if not carefully considered in the piping design. They can cause these loads from the piping can cause pump casing distortion, cracking, misalignment, excessive wear and vibration, resulting in reduced pump performance and reliability, increased maintenance costs, and of course, safety hazards. So all these are the reasons why we have to take care carefully take care about the piping connected to the pumps. Shortly about myself. So in past, I worked in ABB, Alstom, Croatian company Končar. So, and then since 2007, I'm running my own company called Numicon. I and my colleagues, we work together on a lot of projects for different international companies such as GE, Siemens, AFRI, Swedish company AFRI, Italian company Danieli, Inca Fixing Systems from Turkey, Innospring from Switzerland, TÜV Nord Adriatic, and lot of different companies. I mentioned only, let's say, the most important for us. I'm active as a trainer for different trainings related to the piping design and pipe stress analysis. I'm trainer also and instructor for Caesar 2 trainings from static to dynamic, and also for some advanced Caesar training. And also I'm technical support and consulting or coaching for Caesar 2. So these are my, let's say, my background. In these webinars, what I'm preparing for you, what you will learn. So you will learn following things. You will see what are the piping loads and why they are important for pump performance and reliability. You will see different sources and types of piping loads acting on the pumps. So it's not only one type of the loads. There are different type of the loads, sometimes which are, let's say, acting against each other, which additionally complicate our life. We will see how to perform pipe stress analysis using different input data analysis software. Mainly it will be related to Caesar, but everything can be adjusted also to other tools, because different softwares are just tools for us. And of course, we will see how to interpret output, and also to recommend some things related to the piping, or maybe modification for the piping. Also, we will see how to check and verify pipe stress analysis results against different acceptance criteria. In our case, acceptance criteria are different standards which define maximum allowable loads, or even the maximum allowable loads on the pump connection defined by different manufacturers. And also we will see how to optimize or modify this piping design to reduce or eliminate piping loads, and to improve the pump performance and reliability. Of course, we cannot remove the loads from the pump completely, but definitely there are measures and things which we can do to reduce the loads within allowable range. Sometimes this is very hard, but this, what I just said, sometimes it's very hard. It's the main reason why I prepare this webinar. So I believe that by attending these two webinars, you will gain valuable knowledge and skills which can help you to solve the problems with the pumps and piping connected to pumps in the future. Also, you will have a chance to ask me a question, talk to me about any problems you may have. Okay, let's go further. And let's see now a little bit more in detail what you can expect from these two webinars. So for the first webinar, I already mentioned a little bit. I will talk about pumps in different industry. So we have different industry, different pumps, and in different industry, there are some, let's say, common rules which are used how to solve the issues. For example, in some industries, by default, you will use expansion joints at the suction and discharge of the piping. In some industries, for example, expansion joints are not allowed, and then you have to do something else. We will talk about what are the piping loads and why they are important for pump performance reliability. I already mentioned this, but we will talk more in detail about different type of piping loads. For example, mechanical pipe strain forces, so the forces loads due to the weight of the piping itself, and also some other mechanical forces. We will mention hydraulic pressure reaction forces, for example, especially important when you use expansion joint, and also if expansion joints are untied type of expansion joints. And of course, thermal growth or contraction reaction forces. So if the temperature of the medium inside the piping is higher than installation temperature, we will have a growth or elongation of the piping, or if we have a temperature lower than installation temperature, then we will have contraction of the forces. And both of these two things will apply some load on the pump, which we have to take care that the loads are within allowable range. Also, we will see a different effect of piping loads on the pumps. We will little bit touch, I will talk about standards and codes related to the pump. Why standard codes are mostly done for the pump, mostly, let's say, used for the by pump manufacturers. But also, each of these standards specify what are the maximum loads which are allowed to the connections to the pump. This is important for, of course, for the pump manufacturers. So they have to make the pump strong enough to be that the pump is able to take these loads. On the other side, it's important for us what are the maximum allowable forces and moments on the connection which we allow to transfer to the pump from our piping. Also, we will talk about what is pipe stress analysis and why it's important for managing piping loads on the pumps. So this is, let's say, a rough content of the first webinar. Second webinar, we will see methods of piping load analysis, how to use piping analysis software to calculate piping loads and to evaluate the loads. And one thing here is the following. I will talk about why pipe stress and flexibility analysis is important for the piping connecting to the pump, even if piping or the medium inside the piping has very low temperature. Why this is important? Because pipe stress analysis, pipe stress and flexibility analysis will help us to calculate and to get idea about what are the loads which we will transfer to the pump. Nevertheless, that temperatures are very low, and maybe the formal analysis by using of some kind of software is not required. But at the end, the pipe stress analysis, flexibility analysis is the best what we have to get the more realistic results on the connections. Of course, to get the more realistic results to the connection, we have to take care also how we make simulation, how we prepare the model, how we build the load cases, etc. So all this is what we will talk about. And also, I will talk about strategies for piping load management, how to use proper piping alignment, how to properly support, how to properly strain the pipe, what to do when we have to use expansion joints or flexible couplings and things like this. And all of this actually will be covered on some examples. And in conclusion, there will be a summary of key points and best practices for piping and load management, Okay. So, but the question is why checking on the pump nose load is important? Just to, let's say, a little bit talk about importance of the checking of the loads. When designing or calculating piping systems, stress verification and comparing calculated stresses with maximum allowable values is not the only thing what we have to do as a pipe stress engineer. So stresses are not the only thing, what we have to do. We have to check also displacements, and we have to check loads on supports, but also loads in our case, in this case, loads on the pump. So here on this sketch, you can see that we have some, let's say, margin, and with all the results, we have to be here. So if we satisfy, for example, stresses and loads, but we did not check displacement, we cannot say that we did our job. Or maybe we satisfy the stresses and displacement, but we have to satisfy the loads. So we can say that the pipe stress analysis is complete only if we satisfy all these three things. Checking of the load on the connecting pump puts in most cases a more significant challenge ahead of us than solving just stress problems. Experience has shown that in most cases we have more issue with meeting the requirements for the maximum allowable loads on the pump than to solve the stress issues. We will see example. Maximum allowable loads, as I said before, what we have to satisfy are defined by different standards and codes, and also by pump manufacturers. Also, the reason why we have to check the pump loads is that, for example, B31 ASME B31.3 is very precise with requirement that we have to take care about reaction forces on the connections, on the supports, but also on connected equipment. So piping standards are pretty precise regarding what we have to consider and what we have to check. As I already said, load verification poses greater challenge to designer than stress verification. As a good example, we have one table here, which is prepared based on API 610. So this is a standard for centrifugal pumps. And what we have in this table, we have for different pump connections. So pipe size, connection size, we have 3-inch, 6-inch, and 16-inch connections. And here, what we have here are the stresses which we have on the piping when we apply the maximum allowable loads which are defined for certain connections. So, for example, if we have 16-inch pipe and we perform analysis and we apply that when on the connection we have the maximum allowable load, what we will have in the piping, we will have that the pipe is only 7%. The piping has only 7% of the allowable. So you can see that the piping where we are on which we have very low stresses, we are already at the edge of allowable stresses. So, and this is the case, and let's say good example why checking of the loads on the pump is important, because stress results does not give us enough information to say if this is okay or not. Because as I said before, we will have more problems with solving of the load issue than stress issues. So let's see this through one example. So we have one simple example of the pump piping connected to the pump, and also on the other side connected to some vertical vessel. If we perform the analysis and check the stresses, we will see that in this example, we can see that the maximum sustained stress is around 5% of allowable, and maximum expansion stress is around 29-30 megapascal. But when we check what are the loads on the pump, then we can see that we have a problem. For example, if we perform a load check for this same piping according to API 610, it showed that despite the fact that the stress are very low, the loads are very far above the permissible values. So what we can see that with checking of the loads of the forces, we are 6 times above allowable, and checking of the moments, we can see that we are almost more than 12 times above allowable. It is clear that we cannot say that this type of piping meets all the requirements placed on it if the loads on the pumps are too high. Here is important to mention one thing, is that this check is only a screening check. it is not real API 610 check. So you have to be always careful that what are the requirements or what are all the checks, what we have to do or what you have to do based on different standards. So this kind of checking is just a screening check. So if you want to make, let's say, proper analysis, then we have to take care or use appropriate standard. So, for example, since I already mentioned API 610, so here we can see the API 610 allowables from the table, which define allowable forces and moments for different directions, for different connection size, and for different orientation. So you can see that for different, we have different orientation of the nozzle connection, and this is directly related to the type of the pump. So we have to know which pump we have, what is the type of the pump, where is the suction connection, where is discharge connection, and then based on this table from API, we can see what are the maximum allowable loads. And of course, these values are valid with both signs, so plus minus. And also what is important that you can see that for the forces, we have different orientation, but for the moments, we have the same moments regardless of orientation, but we have different moments for different coordinate direction. And also it's important that we always connect these values, forces and moments with coordinate system, which is defined for the certain standard. And typically, you can see my, this is a bending moment around vertical axis on the connection, and this is typically the lowest allowable moment. The most problems we will always have with this moment to solve it. Let's see one example, so a model example. This figure shows the definition of the main details of the pump that are required for simulation in the simulation of the stresses and flexibility. Also, you can see example of modeling both of the connection on the pump itself and also the modeling of the pump piping also. So this is something what is very important, and of course during our training, our webinar, we will go in detail about this explanation, why we have to model something like this, when we have to model the nozzle pump like this, just to cover everything what can have influence on the final loads. Because for us it's important to make a appropriate model to get the most possible correct loads on the connection, pump connection. Okay, and then for let's say I mentioned that we have this screening method, but there is also a approach how to calculate, how to check the nozzle loads, the pump nozzle loads according to API 610 requirements. This here on this slide you can see individual load verification. So of course the first step from the standard is to check individual loads in all directions, so all forces and all the moments. But also there is a requirement in API 610 for 5 additional, let's say, equation which we have to verify. And in most of the softwares, this is from Caesar, we have let's say detailed check of this additional five requirements or additional 5 equations which we have to verify to be able to say that our piping loads to the pump satisfy the API 610 requirements. Okay. So this is shortly about why it's important to evaluate piping loads. So a little bit about the webinars. Here is the link on which you can register yourself if you decide that this webinar will be useful for you. Also, there are 3 options. First option is just to get access to the live webinars, just to get access to these 2 webinars. The second option is to get access to the webinars, but also to get the access or to receive the ebook. And the third option is access to both webinars, get ebook, and also to get 2 hours of one-on-one coaching related to piping to pump related issues. So these are the options which you can and you can select one of these during the registration process. Okay, so as for the end, if you, let's say, if you find out that this is something what can be useful for you, please follow me on the LinkedIn. You have in most of my posts, you have this link, which will take you to the registration page, and hopefully I will see someone of you on to register and to see you next week during this my first webinar. Okay, and now if somebody has some question, let's say we can use 3 more minutes. If somebody has some question, I can answer, and related to organization of the webinars and etc. But of course, technical issues, I will talk about technical issues, technical things during these two webinars. If somebody if somebody has some question, just type in the let's say that you have a question, and I will turn on or turn on your microphone. Okay, I see there is one question. Just a second. Just a second. I hope it will work. Okay, Bojan, you can raise your question. I hope you can turn on your microphone now. Okay, or you can just okay, no problem. Just type in your question. Or also, if somebody else has some question, just type in chat bar, and I will give you an answer. Okay, let's see. Okay, regarding the dates of webinar, yeah, I have a lot of questions about dates of the webinar. Yeah, so I will wait for your complete question. Yeah, so far at the moment it is planned that the webinar will be in the day at dates what you can see on this slide. But I will make a final decision within the next 1 or 2 days. Why? Because yes, you just type in yes, it's holiday season, and a lot of people already ask me if there will be additional webinars or in some other term. So I will see. It may happen that I will postpone these 2 webinars instead of the next week. That I will postpone and do these trainings, these webinars in beginning of the September, because originally it was planned to have it on in June, sorry, but due to some other things what I had to do at that time, I postponed for July. But unfortunately, I was not think about that it's holiday season and that a lot of people are on vacation. So I will let you know all of you who join me on this webinar. I will send you information probably tomorrow, and probably the both of these webinars will be postponed for September. Any other question? Okay, so if there is no other questions, I would like to thank you for joining me for this short, let's say, introduction webinar. Just because I post a lot of information on the LinkedIn, but it's always better that I talk in person to try to explain you what will be the content and what you can expect from these 2 webinars. So Thank you all, and hopefully, if not seeing you next week, hopefully I will see some of you beginning of September. Thank you and bye.